Mathematics made easy, no more fear. Target online class, we got you. Wherever you want to from, we got what you need. Target online class.
Viewers all over the world, you are welcome to Toidel online class. Today we want to look at the applications of integration to kinematics. Kinematics is the study of is actually the study of the distance on a straight line in physics. Okay, so we want to look at the application of integration to kinematics, and that is what we are. That's the point. That's our focus this morning. So we can find the velocity and distance of a body moving in a straight line with a given acceleration after time t by integration. That is, if we are given the velocity, if they are given velocity, by the time we integrate, what is what I'm saying? Before we go to this question, if you have velocity, what is velocity? Velocity is the rate of change of distance, this displacement with time. That is velocity. Is the rate of change of displacement with time. That is velocity. So if you have that, which is a function of t, right? From this velocity, we can actually get the displacement. What do? If we can get the displacement because it's a function of time. If I cross multiply, I can have the s to be equal to ft dt. Then if I introduce integration, by the time I integrate the ds, I'm going to get s. Then x will now be, if I integrate this, I'm going to have f of t plus arbitrary constant. So what we're trying to say is that under differentiation, when you differentiate the displacement, you get velocity. When you differentiate velocity, you get acceleration. But under integration, the reverse is the case. When you integrate velocity, you are going to get displacement. When you integrate acceleration, you are going to get velocity. For instance, this is what I'm trying to say. You know what is acceleration? Acceleration is the rate of change of velocity with time. That is dv over dt. And of course, dv over dt can be actually, it's also a function of time. Let's say g of t. Then if I cross multiply, dv can be equal to g of t dt. So if I use integration, if I integrate dv, I'm going to get v, which is same thing as g of t plus arbitrary constant. So we should note that if you know acceleration, when we integrate acceleration, we get velocity. When we integrate velocity, we get displacement. And when we integrate speed, we are going to get distance. So that is what we should know. So now we want to apply integration because kinematics is one of the application of integration. So we have applied integration to area under curve. Now we want to apply integration to kinematics. Let's look at this question. A particle is projected in a straight line from a point 0 with an initial velocity of 12 meters per second. That's the initial velocity. Its acceleration 6 seconds later is given as this is the acceleration. 6 seconds later is given as this. So we have to calculate its velocity after 2 seconds. We have to calculate its velocity after 2 seconds. Then the big part of the question says that we should calculate its distance from 0 after t seconds. So these are the 2 questions that we are asked to solve. So how do we go about this? We know acceleration. What is solution? So what is acceleration? Acceleration is the rate of change of velocity with time, and it's given us the acceleration 6 seconds later is given us 3t squared plus 2t. That is what our acceleration is given us. So we are asked to find the velocity. Of course, if I cross multiply, I'm going to get dv to be equal to 3t squared plus 2t dt. Okay, that is what I'm going to get. So how do I now get the velocity? I'm going to integrate. Once I integrate the v, I will integrate this other side. If I integrate the v, I'm going to get v to be equal to, if I integrate what I have here, I'm going to have 3. That will be t cubed over 3 plus 2t squared over 2 plus arbitrary constant. Please note, when we integrate indefinite integral, it is a must that we have the arbitrary constant. But I'm leaving this one is definite integral. It has to one upper bound. Then we can let go. we can just disregard the arbitrary constant. So from here, this we cancel this we cancel this. V is actually given as t cubed plus t squared plus c. That is V. That's value over V. But remember that remember that at point 0, there's an initial velocity of 12 seconds. So we are going to do that for us to be able to know the value of C. That C is an arbitrary constant. So it's a subsidiary conditions. For us to be able to get that, we must substitute the value of velocity at 12 and time at 0 for us to be able to know the value of C. That is, we say V is 12. So we say 12 is equal to the time at point 0, the initial velocity is 12. So we say 12 at 0, that's 0 cube plus 0 squared plus C. So C is equal to 12. That's what we are going to get. So finally, the value of V, the velocity, will now be t cubed plus t squared plus 12. So we have been able to get the value of that C because C is arbitrary constant. For us to be able to know the value of C, that is what we are going to do. So that is V is equal to what we have. So after 2 seconds, the value, we are going to get the value. This is the value when T at 0, at point 0, this is the value. We got it to be 12. Then we also have to find its velocity after 2 seconds. So what will be the velocity after 2 seconds? That's what I'm about to do now. The velocity after 2 seconds. How do I get that? After 2 seconds. After 2 seconds. So after 2 seconds, after 2 seconds, the velocity will now be, the velocity is t cubed plus t squared plus 12. So after 2 seconds, the velocity will now be 2 cubed plus 2 squared plus 12. This is when at initial stage, at time 0. But after 2 seconds, what will be the velocity? The velocity will be, this is 8 plus 4 plus 12. So the velocity will be 12 meters. That will be, no, this will be 24 meters per second squared. So that will be the velocity. And that actually answers the first part of the question. So after 2 seconds, the velocity is actually 24 meters per second squared. Then we go to the B part of the question, where we have to find the distance. Is distance from 0 after 2 seconds. Of course, B, we know the velocity now after 2 seconds. So how do we get the distance? What is velocity? Velocity is distance all over time, or displacement all over time. Then this is given us, when we calculate at point 0, we're able to get our velocity to be t cubed plus t squared plus 12. Okay, we don't want to find its distance, this distance at point 0. Okay, if you cross multiply, ds is equal to t cubed plus t squared plus 12 dt. If we integrate, we introduce integration into integration, this will be x will be equal to t quarts all over 4 plus t cubed all over 3 plus 12t plus arbitrary constant. That is what we are going to get. So when we integrate, that is what we are going to get. But we are looking for the distance. Is distance from 0 to after 2 seconds. That will be from 0. The distance from 0. This is t quarts, t raised by 4. From 0 to t. That is the implication. Is distance from 0 after 2 seconds. So that's what we are going to do. So here we are going to have this value from 0 to 2. Of course, we can disregard t. C. We have t quarts all over 4 plus t squared all over 3 plus 12t is 0 to 2. 0. We have to find the distance. That's what we have to find. We have to find the distance. Is distance from 0 after 2 seconds. So because this is a definite integral, we don't need to, we can disregard this arbitrary constant because it's going to cancel out. So let's substitute. When t is equal to 2 raised to the power 4 plus 2 raised to the power 2. This is 2 raised to the power 3. 2 raised to the power 3 all over 3 plus 12 into bracket 2. That's what we have for the upper. Then for the lower, everything has t, so it will be 0. We don't bother ourselves with that. Here will be 16 all over 4 plus 2, 8 all over 3 plus 24. Here 1, here 4. So I'm going to have 28 plus 8 all over 3 minus 0. That's what I'm going to have. So if I find the LCM there, if I find the LCM here, I'm going to have 3. This will be 84 plus 8. Then that will be 92 all over 3. So 92 all over 3. This same thing as 92 all over 3 will be 30 whole number. That will be 30 whole number 2 over 3. So here I'm going to have 30 whole number 2 over 3. So this will be the distance meters. So this will be the distance from 0 to 2t. So this is the distance that we are asked to find. Thank you.
Mathematics made easy, no more fear. Target online class, we got you. Wherever you want to from, we got what you need. Target online class.